Hello students, welcome back to a new mathematics program for grade 8. Today we're going to talk about algebraic terms. Well, this video is the first part of a series of 3 videos based on this chapter, that is algebraic terms. In this program, you're going to learn how to find LCM of algebraic terms. To begin with, let's do a recap on certain things that you have already learned in grade 7. First, let's see how to write an integer as a product of its prime factors. Remember, in grade 7, you have used prime factors to find LCM of integers. So here again, we are going to recap on how to write a number as a product of its prime factors. Like here we have 12. 12 can be written as 2 times 2 times 3. Another example, 24 can be written as 2 times 2 times 2 times 3. Can you tell me how to write 105 as a product of its prime factors? Yes, it is, of course. 3 times 5 times 7. Students, you also learned how to write a number from index form to expanded form. That is, if we have a power 3, we can write it as a times a times a. Similarly, for a square b to the power of 3, we can write it as a times a times b times b times b. Suppose now we have 9 p power 3 q. We have an integer value together with an algebraic terms. So first we write the integer value as a product of its prime factors, then we write the algebraic terms in expanded form. So we have 3 times 3 times p times p times p, then times q. Students, remember that you learned how to find LCM of integers in grade 7. You have used 2 different methods. The first one was using prime factorization. So to find the LCM of 18 and 24 using prime factorization, first we write the integers as a product of their prime factors. Like here we have 18 is equal to 2 times 3 times 3, 24 equal to 2 times 2 times 2 times 3. To find the LCM, we need to take one term from each column, then we multiply them. So the LCM of 18 and 24 is 2 times 2 times 2 times 3 times 3, which is equal to 72. Remember that you cannot write 2 different elements in the same column. Like here in the first column we have 2, in the second column we have 2, in the third column we have 3, and the fourth column that we are having 3. And again in the fifth column we have 3. Remember again, you cannot write 2 different elements in the same column. You have also learned how to find LCM of integers using the method of index form. That is, we write the 2 integers in index form. Of course, we use their prime factors, but instead of writing them in expanded form, we write them in index form. Like here we have 18 is equal to 2 power 1 times 3 power 2. For 24 we have 2 power 3 times 3 power 1. Now to obtain the LCM, we're going to use one term from each column, but we need to take the term with the highest power. Like for 2 in the first column, we are going to take 2 to the power of 3 because the highest power of 2 is 3. In the second column we have 3, the highest power of 3 is 2, so we're going to take 3 power 2. So the LCM is 2 power 3 times 3 power 2, which is equal to 72. Now my dear friends, I'm going to show to you how to find LCM of algebraic terms. Again, we are going to use the 2 different methods that you have used in grade 7. Example 1, we're going to find the LCM of AB and A square B. Using the method of expanded form, first we are going to write AB as A times B. Then A square B is A times B. Again, you need to remember that we cannot write two different terms in the same column. Like here in the first column we have A, in the second column we have A, and the third one we have B. So the LCM is A times B, which is of course A square B. Now let's see how to use the second method to find the LCM of, again, AB and A square B. We are going to write AB and A square B in index form. So AB is equal to A power 1 times B power 1. A square B is A square times B power 1. Now we are going to take one term from each column, but the term with the highest power. The highest power of A is 2 and that of B is 1. So the LCM is A power 2 times B power 1. The final answer is A square B. Let's take another example. Find the LCM of AB to the power of 3 and A square B square. Using the expanded form, we're going to write AB cube as A times B times B times B, A square B square as A times A times B times B. We're going to take one term from each column. So the LCM is A times A times B times B times B. We need to write the answer as A square B cube. We cannot leave the answer in expanded form. Concerning the second method, for AB to the power of 3 and A square B square, we're going to write these two algebraic terms in index form. So AB to the cube is same as A power 1 times B power 3. A square B square is equal to A square times B square. We're going to take one term from each column. Remember that we need to take the term with the highest power. The highest power of A here is 2 and the highest power of B is 3. So the LCM is A square B to the power of 3. Example 3. Using expanded form. Okay, so we need to write them in expanded form. P q to the power of 3r and P cube qr square. As you can see here, we have written these two terms in expanded form. Now, how to find the LCM? Yes, we're going to take one term from each column. So we have the LCM as P times P times P times Q times Q times Q and R times R, which is of course P to the power of 3, Q power 3 and R square. Using the second method, we write these two terms in index form. Then we take one term from each column having the highest power. So the LCM here is P power 3, Q power 3, R power 2. Because in the first column, we have the highest power of P as 3. In the second column, the highest power of Q as 3. And in the third column, the highest power of R as 2. So the final answer is P to the power of 3, Q power 3, R power 2. Example 4. As you can see here, we have three different algebraic terms, but the procedure remains the same. We write them in expanded form. Then we take one term from each column. So the LCM is P times P times P, Q times Q times Q times R equal to P power 3, Q power 3, R power 2. Using the second method, again, even if you have three different terms, the procedures remains the same. We write the terms in index form, then we take the element with the highest power from each column. Here in the first column, the highest power of P is 3, the highest power of Q is 3, and the highest power of R is 2. So the LCM is P power 3, Q power 3, R power 2. Example 5. Here you will see that in the algebraic terms, we have an integer value together with an algebraic terms. So to write this term in expanded form, first we need to write the integer value as a product of its prime factors, then we write the algebraic terms in expanded form. So for 6ab cubed, we have 2 times 3 first, then a times b times b times b. For 10a squared b squared, first we write 2 times 5, these two are the prime factors of 10. Then we write a squared b squared as a times b times b. To find the LCM, we're going to take one element from each column. So the LCM here is 2 times 3 times 5 times a times b times b times b. Then we write the final answer as 30a squared b cubed. 30, that is 2 times 3 times 5. Using the second method, okay, we have the algebraic terms with the integer values. We write the integer values as index form, then the algebraic terms. So the LCM here is to take one element from each column, but the element with the highest power. In the first column, we have the highest power of 2 is 1, the highest power of 3 is 1, and the highest power of 5 is 1. Concerning the algebraic terms, the highest power of a is 2, and the highest power of b is 3. The LCM is 2 power 1 times 3 power 1 times 5 power 1 times a squared times b cubed. We write the final answer as 30a squared b cubed. One last example. Here we have 3 different terms, and as you can see, the terms contain integer values and algebraic terms. Can you tell me which method we are using here? Yes, it is expanded form. So we take one element from each column to have the LCM as 2 times 3 times 5 times p times p times p times q times q times q times r times r. So the answer is 30p to the power of 3 q power 3 r squared. Using the second method, index form, can you think how to write these terms in index form? Yes. And the third one? Of course, 2 power 1 times 5 power 1 times p squared times q power 1. How to obtain the LCM? Of course, we take one element from each column, the element with the highest power. So we have the LCM as 2 power 1, 3 power 1, 5 power 1, p power 3, q power 3, r power 2. The final answer is 30, p power 3, q power 3, r power 2. Now, my dear friends, I'm going to give you some exercises for practice. You're going to find the LCM of the following. You can use both methods, or you use the method that you feel more at ease with. If you have any difficulties, you can always take the help of your teachers or parents. If you want to have some more information concerning this chapter, you can log on these websites. So students, in this program, you have learned how to find the LCM of algebraic terms using the method of expanded form, then the method of index form. So students, this program ends here. Remember that this video is the first part of a series of 3 videos based on this chapter. In this part, you have learned how to find the LCM of algebraic terms. In the second part, you're going to learn about algebraic fractions. Till then, goodbye.